Japanese quality control practices are famous today throughout the world. Perhaps the most well-known feature of quality control, as it is practiced in Japan, is the QC circle. The QC circle brings the workers from a job site together to think up suggestions for improvement. These QC circles have come up with some truly wonderful improvements that not even trained engineers would have been able to suggest. It is because of this that foreign visitors on tours of Japanese factories always ask to see a QC circle in action. We might ask ourselves why these QC circles have been so successful. They did not succeed merely by gathering workers at a job site together for discussion. They succeeded because they had several useful tools for improvement. As you all know, our solar system has 9 planets, one of which is named Saturn. Saturn, of course, is surrounded by rings, and it was Galileo, the famous Italian astronomer, who first discovered them. Why was Galileo able to discover these rings? It was because he was aided by a tool, the telescope. However good his eyesight may have been, Galileo never would have been able to see the rings of Saturn with the naked eye. In the same way, I would first like to stress that the QC circle has succeeded because it has had some handy tools to work with. Let's stop for a moment to consider the game of basketball. As you know, basketball is a sport that tends to attract tall players. Let's consider the case now of 2 basketball teams. Team A was far and away the stronger of the 2. Thus, although Team B also had some outstanding players, it somehow could not hold its own against Team A. If you've ever seen a basketball game, you know that a team composed almost entirely of tall players will monopolize the ball. Tall players can send the ball sailing over the heads of the shorter players, who may not even get a chance to touch it. Now, the people on Team B wanted to find out if Team A was stronger because it had a tall lineup of players. They therefore set about collecting data with an eye to creating some graphs. Let's take a look at the graphs they came up with. If we examine this graph carefully, we find that not all of the players on Team A are tall. One of the players is under 170 centimeters in height, less than 5.5 feet. On the other hand, there are some players as tall as 184 or 85 centimeters, over 6 feet tall. As you can see, this chart is marked with a number of tallies. These tally marks represent the head count in each class. If we put the 2 graphs side by side and compare them, it does somehow look as though Team A has a larger number of tall basketball players. In quality control, these strokes or tallies are known as check marks. The chart itself is called a check sheet. You may find it difficult to make comparisons on the basis of a check sheet alone. To make the contrast between teams A and B clearer, we've created 2 bar graphs using the same data. Here is the product of our efforts. With the same data reformed into a bar graph, you can see at a glance that Team A really does have quite a lineup of tall players. There are, of course, some very tall individuals on Team B as well, but they are small in number. Comparing these 2 teams, we see clearly that the mean or average value for Team A is higher than that for Team B. We can also tell that the number of tall individuals is greater for Team A. Graphs of the type you have just seen are called histograms. Histograms are suitable for use in situations where you're dealing with an attribute like height. Or consider the planing process that is sometimes employed in manufacturing. Objects planed under identical conditions will not necessarily all come out the same. There will be a certain dispersion from the average. You will find, when you're trying to judge the extent of a dispersion, that check marks do not give the eye very much to go on. It is better to prepare a bar graph using the same data. With a bar graph, it is possible to make very clear distinctions between high-frequency and lower-frequency items. And, as you will see later on, a bar graph makes it easy to compare readings against various kinds of standards or other criteria. You can thus get a clear idea of just what the problem is. The histogram is one of the essential QC tools.
いったようなことがですね、はっきり出てまいります。7つ道具の一つがここに書きましたヒストグラムです。
The check sheet is yet another QC tool, one that makes the facts present themselves clearly in data. These facts can then be used to promote improvements and control. Let's now consider the goals and proper use of this helpful QC technique.
A while back we were talking about the height of basketball players. Data on attributes such as height is measurable and can be expressed numerically in meters and centimeters. If you want to organize and represent data of this type in graphic form, the histogram is a good vehicle to choose. Since the data belonging to this category can be quantitatively measured, the terms measured values or continuous data are used. There is, however, another type of data. We may want to consider a yes-no situation, such as whether or not a customer has submitted a claim for compensation. We may also want to consider whether a product is good or defective, or whether or not articles have been left behind in a place by their owners. Data of this type is a little different from continuous data dealing with height or some other measurable attribute. Because we need here to count the number of cases or items, the terms counted values or enumerated data are used. When it comes to arranging this countable data in graphic form, there are several alternatives from which you can choose, but the check sheet is especially convenient. Let's take a look at this chart, for example. Customers who have bought cosmetic products often make various claims for compensation, and this chart was prepared to tell us which kinds of claims are made in each of the regions of Japan. Looking at this chart, we see that a wide range of different claims are made regarding cosmetic products. Some customers complain that the products they purchased were short of content. Others claim that the container is cracked or dirty. The residents of Tokyo seem to be very sensitive to shortage of content. Surprisingly, we find that the Osaka customers had few complaints regarding shortage of content. A glance at this check sheet also tells us that the residents of Sapporo City in Hokkaido submitted a large number of claims regarding cracked cosmetics containers. Along the horizontal axis of this check sheet, we've written the kinds of claims received, and the vertical axis represents the breakdown of regions. One check mark was entered in the appropriate block for each claim that came in. With a completed graph of this type, it is possible to tell at a glance what kind of relationship exists between region and the nature of the claims made against the cosmetics maker. A chart of this type is called a check sheet.
A check sheet is a chart made by combining into totals data collected through a process of making and recording observations regarding events or objects at a job site. Check sheets can be used to aid routine administration of a task or job site. They can also be used as necessary in research or analyses on special topics for specific goals.
This is a diagram of a glove. It is also a check sheet made by a factory that mass produces gloves to show the spots where defects are noted to occur. As you will see immediately by examining this check sheet, defects are not scattered at random on the glove. They always seem to appear in the same areas. Now please look at this next diagram. This drawing represents an automobile tire. Since an automobile tire is perfectly round, you might expect the points where defects occur to be evenly distributed all over the tire. But this is not the case. If you gather data and create a graph, you will see that defects always occur in the same areas. Thanks to this check sheet, the reasons why defects routinely occur in specific areas could immediately be determined. In the tire production process, metal molds are used to shape the rubber, and it was soon found that these metal molds themselves had defective spots. When these spots were mended, the number of defects in tires dropped. So, as you can see, we can do many things with check sheets. Let's turn now to another diagram. This is actually a floor plan of the customer service area of a bank. It was made to show just where in the bank customers tend to leave behind their belongings. Various procedures are carried out in a bank. Money is paid out to customers and deposits are accepted. And for each of these procedures, a bank slip must be filled out by the customer. Now, in the bank customer service area, there are a number of counters where these slips can be filled out. Customers seem to be especially prone to leave behind belongings at these counters when they stop to fill out forms. and this is clearly illustrated by the diagram. Thus you see that a check sheet doesn't have to take the form of an ordinary table with columns and rows. It can be shaped like a glove, or a tire, or a room within a bank. You simply mark the areas on any kind of diagram at which defects or other problems occur. I think that by now you can see how useful diagrams prepared in this manner can be. I would like you all to take a look at one more interesting check sheet. This check sheet was made to show what points consumers are especially attentive to when purchasing cameras. Quite a number of things can be learned by examining this chart. Separate check sheets were made for male and female customers, and many kinds of selling points and other considerations are listed. For instance, we see that some people give much thought to a camera's performance when making a purchase. Others are most concerned about price. These and many other things can be learned from this chart. But one rather surprising fact revealed here is that many women are particularly attentive to performance when choosing a camera to buy. But one even more interesting discovery was made. At the bottom here you see the word advertising, and the number listed beside it is not large. This means that only a few of the people surveyed are influenced by advertising in their camera purchases. All camera makers have to sell their products, and in an effort to do so, they rely upon various types of newspaper and other advertising. But oddly enough, it seems that the influence of advertising on the customers is not very great. Most of them still seem to buy on the basis of product performance or price. And women, it is interesting to note, sometimes buy on the basis of ease of operation, how the product feels in their hand. All these things can be learned from these two check sheets.
Let's learn how to prepare a check sheet using as example this list of classified totals for cosmetics claims. First, have all the people involved in the study zero in on the specific problem points and clarify the objectives of the check sheet. Do a careful inquiry, attempting to answer the question of what exactly needs to be found out and list up the items under which check marks will be entered. Decide the overall form your check sheet will take and prepare a first draft, determining the position of the headings, the size of the lettering to be used, etc. Complete the check sheet by filling in the data. Make changes if necessary to ensure that the dispersion of data is clearly visible and the graph fulfills its purpose. Define your objectives clearly. Have all personnel at a job site participate in check sheet preparation. Specify the term of data collection. The histogram is a very useful means of representing a set of data, having a dispersion so that the whole array can be viewed at once and readily understood. Let's now look at how the histogram is used.
The goal in many factory situations is to produce a large number of identical items. You will find that the histogram is the simplest means of examining how these individual articles differ from each other. When factories mass-produce large numbers of an item, they of course use the same materials throughout in identical machines, all set at the same settings. Care will also be taken to see that assembly procedures are consistent throughout. But however hard we may pursue uniformity, there will of course be some variation in the quality of materials. The condition of the machinery may also vary some from morning to night. Thus, when you produce something, aiming for certain dimensions or other measures of quality, you'll find that while it is possible to fulfill these requirements in the majority of the articles produced, a certain amount of the output will exceed or fall below your standards. We use the histogram to get an overall picture of the range of dispersion. Preparing a histogram makes it very easy to locate abnormal phenomena. Let's have a look at another graph. This is a histogram of shaft thicknesses prepared by a factory that makes micromotors. A very high degree of precision should be maintained in the production of micromotor shafts. But in this graph, we see a second small isolated mountain to the right of the main peak of the dispersion. Just by looking at this graph, we can tell that something went wrong at the time of production. Investigating further, we learn that the defects occurred because the shaving step had been neglected. Shaving is a process by which the surface of the grindstone used in finishing the shaft is prepared for use. A histogram makes it very easy to grasp the overall situation, and I think you can see what a convenient type of graph it is.
A histogram is made by dividing the range in which data exist into a number of classes, determining the frequency of data for each class, and presenting a graphic representation of those frequencies. A histogram aims to make it possible to correctly assess changes in quality characteristics by providing a graphic means of determining the form and nature of a distribution or dispersion.
This is a graph that was made by a group of university students assigned by their teacher to create a histogram. To make the project interesting, they decided to hunt for some unusual data. The school grounds were littered with discarded cigarette butts, and the students decided to collect these and create a histogram of cigarette butt lengths. The resulting graph is rather odd in appearance. As you can see, there are two distinct peaks to this graph. Wondering why this was so, the students did a little investigating and discovered that there are two kinds of smokers. One lights his cigarette, takes just a few puffs and then throws it away. The other smokes his cigarette right down to the end. It was this difference in smoking styles that showed up on the graph. In other words, the group of smokers that discard their cigarettes as soon as they light them was represented on the graph in one peak, while the other group, the less extravagant smokers, accounted for the second peak. I have another rather odd little story about histograms. In Europe, as in Japan, there were severe food shortages during the war, and a system of rationing had to be adopted. At this time, there lived in Germany a certain university professor who was supplied with bread by a certain baker. One day, this professor summoned the baker and complained that the bakery was providing him with less than his fair share of bread. At this, the baker was astonished, for he always made a point of specially weighing out the bread that he delivered to the professor, something that he did not do for other customers. About a month passed, and again the professor came to the baker with the same complaint. The baker protested that the professor really was receiving his fair share, and this time he was armed with a graph to prove his point. A histogram is supposed to be fairly symmetrical on the right and left-hand sides of the peak, but here, as you can see, the left-hand portion is cut off abruptly at a certain point. This tells us that there was indeed something odd about the way the baker supplied the professor. The fact was that the professor was so hard to please that the baker weighed each loaf of bread destined for delivery to his home and sent only the ones that were on the heavy side of the standard. A glance at this graph was enough to convince even the stubborn professor.
Let's practice making histograms using as example a graph that examines the heights of the players on a basketball team. First, we divide the set of characteristic values, in this case heights, into about 10 to 15 classes and check off in each class the number of individual data that belong in it. To set up the frequency table, first find the highest and lowest values among your data. Next, determine the number of classes, the class interval, the class boundary values, and class mid values. Calculate the number of data and enter them into the frequency table. Make this frequency table into a bar graph, having frequencies on its horizontal axis and height classes on its vertical axis. This bar graph will function as a simple histogram. Now let's consider the outstanding characteristics of the histogram. 1. It is possible to tell if a process is stable or abnormal just by looking at the shape of a histogram. This histogram indicates a stable process. As you can see, it forms a symmetrical bell curve. These precipitous type, jagged type, small isolated peak type histograms tell us that something went wrong in the production process. Two, histograms with specification limit lines drawn in can be used to determine whether values fall within a standard range. With a histogram, it is easy to see how the data compare with standards. If the dispersion is too wide or the average value too high, the standard may not be met. Three, stratifying a histogram on the basis of causal factors makes it possible to analyze the effects of these factors.
ヒストグラムは私たちがある目標を立てて、でそのためにいろいろな製造条件その他を、いい状態に保つ。そういたしますと、どのぐらいばらつくかと。
When we manufacture something, we establish certain goals or standards and attempt to maintain good production and other conditions with an eye to meeting those goals. A histogram can immediately tell us how far the product quality strays from the standard range. We have already seen this in several examples. You will find when you actually prepare histograms that you do not necessarily get a neat distribution that is symmetrical on both sides of a central point. Some graphs have very wide dispersions and are almost flat across the top. In other cases, such as the cigarette butt study we previously examined, you will find a histogram with a double peak, a so-called bimodal distribution. Still other times, the majority of the values will fall within a certain range, but other values will form an isolated island of their own. In these cases, we must figure out what caused the strange arrangement to occur. You will find that stratification is very useful as a method of determining the reasons for unusual dispersions. When we make a certain product, we must always deal with a number of interacting conditions. It is possible to divide these interacting conditions into groups and draw a separate histogram for each. We previously took up the example of the cigarette butt length histogram, and you'll recall that there were two distinct peaks in that graph. The creators of the graph made separate histograms for each kind of smoker, and from these it was possible to see that the first histogram really consisted of two overlapping mountains. Now I'd like you to take a look at this graph. The electrical maker that prepared this graph was purchasing steel sheets from an external materials supplier. Since hardness is a crucial factor in the finishing of steel sheets, this electrical maker tried measuring the hardness of the steel provided to him by the supplier. Creating a histogram with the data gathered, he found that it formed a very wide dispersion. Some of the steel sheets were too hard and others were too soft to meet the standard. The electrical maker then tried to identify the cause of the wide dispersion. Inquiring at the suppliers, he discovered that the steel sheets were purchased from two different companies. The electrical maker then divided up the data on supplies from Company A and Company B to create two separate histograms. As you can tell from these graphs, the output of Company A tends to be on the hard side. There were no cases in which supplies from this company did not meet the standard because they were too soft. Nevertheless, some of the output did exceed the hardness standard. The graphs also clearly show that the dispersion for supplies from Company B was extremely wide, with some of the output too soft to meet standard and some of it too hard. When carrying out a program of quality control, we must naturally try to pinpoint the reasons why such phenomena as wide dispersions occur. If a histogram we've drawn yields a peculiar form, as previously seen, we can stratify the data upon which it was based and create a new set of histograms to zero in on the cause of the problem. This investigation can then form the basis for remedial action.
係数値の場合にはチェックリストというこういうやり方によってどういう対策を立てることができるかというその手が見つかるわけであります。
Get clues to process abnormalities from the shape of the histogram. Check to see whether or not the values are within your specification limits. Look into the reasons for wide dispersions or skewing.